Now let us look at set operations. If the sets are stored in an array, then how we can perform those operations. So the operations are performing union of two sets, intersection and difference, set membership. So here I have example of two sets that are stored in arrays A and B. Some five elements I have taken. And I have taken one more example here. The difference is these elements are not sorted, but these are already sorted. So let us see how we can perform these operations if the elements are not sorted and if they are sorted. So let us look at union operation. Let us see how to perform union. So for that I will say this is having m elements and this is having n elements. Now what is the procedure? Copy all the elements of first array 3, 5, 10, 4, 6. So the first set is copied. How much time it has taken? M. Then I should copy second set 12. Shall I copy it or not? See, I cannot blindly copy second set. If already it is present here, I should not copy it. 12. Search for it. Is it there? No, not there. Then copy it. 12. 4. Search for it. Is it there? Yeah, it's there. So don't copy it. Then 7. Search for it. Is it there? No, not there. So copy it. So every element I am searching here. Searching takes how much time? Depends on the number of elements present here. So already I have copied those elements here. So m elements are there. So it is taking order of m. So it is taking m time for searching. So let us continue. 2, is it there? Not there. So copy it. 5, it's there. So don't copy it. So 4 and 5 were already present here. So those are not copied. So every element we have to search. So how much time it is taking? M is the time taken for searching. No doubt the elements are increasing afterward, but let us say m is the time for searching. How many times we have done this one? For n times. So into n. So the total time is m is for copying first array elements. Then second one is copying second array elements, that is second set's element, but every element has to be compared. So this is m plus m into n. So this is the highest degree, m into n. So we will not use two variables, we will take single variable only. So let us call this as n plus n into n, that is n plus n square. So this is order of n square time. So for performing union it has taken n square time. This is very slow. This is quadratic, time consuming. Now let us see, if we have sorted elements in the sets, then how we can perform union on those sets. Let us see. Let us say these are m elements and these are n elements and these are sorted. I have to combine them and store them in C without duplicates, that is union. So I can use merge procedure here. We have already learned what is merging. That same merging procedure we will perform. So what we will do is, let us say here is I and here is j and here is k. Compare a of I with b of j. B of j is small. Copy this 2. Then move j and move k. A of I with b of j. So a of a is small. So 3. Copy it. Then move this one. A of I and b of j both are same. So copy that 4 and move I also and j also, and k is here. So if they are equal to this one. Now again a of I with b of j, both are equal. Copy it once, move I also and j also, and k is here. Compare a of I with b of j. 6 is small, so copy this one, move I. A of I with b of j. 7 is small, 7 is copied, move j. A of I with b of j, 10 is small, copy 10. Then leftover is 12, so copy that 12. So this was merging. Only a slight change is that if they are same, copy only once and move both I and j. So it is merge process, so it is m plus n. We can say this is theta of m plus n. If you want to represent this in a single variable, then you can say theta of n plus n. This is nothing but 2n, so 2 is coefficient, so leave it, n. So this is order of n. So if the list are not sorted, it's n square. If they are sorted, then it's n. So that's all. This is about union. Now next is intersection and difference. So we don't have to learn much there. Now already we know how to perform union. They are similar with some changes in them. Now let us look at intersection. Intersection of two sets. We have to take common elements of A and B and store them in C. So the procedure is start checking the elements of array A, copy them in C. But before copying, check if this element is already present there. It's not there, so move to the next element. Is it present here? Yes, it is present. Copy that 5. So I am checking this element in this one. So I am searching for that element here. How much time it takes to search for any element here? Like 5 I am searching, so it's take n time. Then search for 10 also, search for 4 also. How much time it takes for all m elements? So this is m into n or n into m. Then check next. 10, is it there? It's not there. Move to next. 4, is it there? Yes, it's there. Copy 4. Then move to next. 6, is it there? It's not there. Don't copy it. So while copying the elements from array A into C, check if they are also present in B or not. That's it. So every element I have to search here in n elements, and I have to search all m elements. So m into n. So if we write it in single variable, then it is n into n and it is order of n square. So this is also time consuming. Now let us see how to perform intersection if they are already sorted. So here also we use the same procedure of merging. So for merging, let us start indices from 0 of each list, that is I, j, k. And in merging, we check which is smaller, A of I or B of j, which is smaller. This is smaller. Don't copy it. We don't want that element. Move next. Then compare A of I with B of j. That's smaller. Don't copy it. Move next. Now compare A of I with B of j. Both are equal. We want that element. So copy that element 4, move I as well as move j and move k. This is not merging but similar to merging. So we are using that procedure. Then compare A of I with B of j. They are same. So copy that 5, move I and move j and move k. Then compare A of I with B of j. 6 is smaller. Move next. Don't copy it. Then B of j is smaller. Move next. Then A of I is smaller. Move next. Finished. That's all. Stop. Don't have to copy anything. So the procedure is same as merge procedure, and the time is theta of m plus n. In a single variable, it is n. So in union, if you remember, we were copying all the elements and duplicates one time, but in intersection, we are copying only duplicates. Now the next operation is finding difference. Next operation is a set difference, that is difference operation. We have two sets, then we say A minus B, that is subtraction of two sets. A minus B means we want all those elements of A which are not there in B. So subtract the common elements between A and B and take only those elements which are only in A, not in B at all. So this is a difference operation. How to get those elements? So what are those elements? Let us see. See, 3 is not present in B, 3 is in the result, 5 is there, don't take it, 10 is not there, take it, 4 is there, don't take it, 6. So 3, 10 and 6, these are the 3 elements that comes after A minus B. So how to perform this operation? So we have to copy all the elements of A, but copying every element, check is it present here? 3 is not present, copy it. 5 is present here, don't take it. 10, it's not there, take it. 4, it's there, don't take it. 6 is not there, take it. So every element of A is compared with all the elements of B, and if it is not there, then we are copying it. So we are searching here. So m elements are copied, and every time they are searched in n element. So this is m into n. So in single variable, this is n into n, and this is n square. So the time is n square. Now how it has to be done in sorted sets, if the lists are sorted, then how to do that, let us see. We can again use the merge procedure. So we will take indices I, j and k. Now we will run the process similar to merging. Let us start. A of I, B of j, this is small. So we don't want the element from B at all. Move ahead. Compare A of I with B of j. 3 is small, copy it. Then move ahead. They are same, don't copy anything, just move ahead. They are same, don't copy anything, just move ahead. That's small, copy it. Move ahead. Then this is small, move ahead. Then that is small, copy it, move ahead. First list has finished, so stop. We are not copying from B, we are copying only from A. And we are running the same procedure just like merge. So the time is m plus n theta, and in single variable it is n. And there is one more last operation, set membership operation, that is to know whether an element belongs to a set or not. Like 10 belongs to set A or not. So search and find out, yes, it's there. So set membership is same as searching only. So that's all we have learned about set operations. Mostly they are binary operations. So that's all about operations on an array, that is ADT topic. So that's all. We have seen various operations on an array, that is on a single array, as well as binary operations, that is more than one array also we have seen.